Okay, so today we're going to learn how to integrate using linear partial fractions. In this particular example, we're going to go over how to use partial fraction decomposition with distinct linear factors in order to help us rewrite our integral like we have here in our example. So this is a little bit review from pre-calculus, and if it isn't something that you've seen in pre-calculus before, or perhaps you just didn't have pre-calculus, I'm sure with your algebra skills you're going to be able to pick up how to find your partial fractions. Okay, so the first thing that we're going to do is actually find just that, your partial fraction decomposition. So we have here 5x minus 3 over x squared minus 2x minus 3. What we're going to do is find out what fractions we can combine together to give us this one. So what you would do is factor your denominator. X times x is x squared. 3 times 1 is 3. And if this one is negative and this one is positive, my outer and inner terms would be negative 3x and positive x, giving me a negative 2x for my middle term. So I know that I factored this trinomial correctly, as well as it gives me a negative 3 when I multiply my last terms together. Now, I don't know what the numerator is going to be for each of these factors, okay, that exist in my denominator. So I'm going to label it as A and B. They are constants. Whenever you describe your denominator as linear, in this case these are distinct linear factors, it's 1 degree less. So if this is to the first power, okay, so the degree of my denominator for the first fraction is 1. That means the degree for my numerator should be 0. It's like 1 less. So that's why I just use a by itself. It's whatever the coefficient would be, because x to the 0 power is 1, and 1 times a is a, so it's just a. So a little background story. Let me erase that and let's continue. So now hopefully you understand the setup, and there's 2 ways to actually solve for A and B. Alright, and what we're going to do at this point is multiply my equation by the common denominator, which in this case is x squared minus 2x minus 3. So if I multiply it to the left side of my equation, I get 5x minus 3. If I multiply it to the right side of the equation, I have to multiply it to both fractions. So x minus 3 is going to cancel out with part of my x squared minus 2x minus 3, okay, because it'll cancel out one factor but not the other. Okay, and the same thing, or I should say similarly, something like that will happen when I multiply it to my second fraction. Okay, the x plus 1 will cancel with the factor of x plus 1 in x squared minus 2x minus 3, leaving me with b to be multiplied with x minus 3. Okay, so like I said, there's 2 ways to solve. So the first way would be, I would say, match coefficients. So this is ax plus a plus bx minus 3b. So a plus b is being multiplied by x, and we know that 5 is being multiplied by x here. So a plus b is equal to 5, that we know. And then our constants on the right-hand side are a minus 3b. So my constant on the left-hand side is negative 3. So a minus 3b, that's a minus sign, is negative 3. So what we can do here is multiply the bottom one by a negative 1 or a lot of people just subtractions, technically called the addition method. So you would have a minus a, b minus a negative 3, so it's b added with a positive 3b, so it's 4b, and 5 with a positive 3 because you're supposed to negate it, and you get 8, so b would be 2. Okay, so we know that b is 2. Let me erase this and write down that this is 2. Okay, and let's continue to solve for a. So now if we know that b is 2 and a plus b is 5, then a plus 2 is 5. A has to be 3. Okay, so we just found out that this is now 3. And like I said, this is one way to kind of solve for a and b, is to match the coefficients. Another way is to eliminate factors. So we have a factor here of x plus 1. It could be eliminated if x is equal to negative 1. So let's make x equal to negative 1 wherever we see x within our equation. So that gives us, on the left-hand side, negative 5 minus 3, so it's negative 8. And on the right-hand side, a negative 4b. So b would have to equal 2. Okay? And b did equal 2. We have that there. All right, so now let's look at the next factor that we saw here. Let me change the color. Maybe blue would be better. So if we look over here, what would make this factor equal to 0 and eliminate this whole thing here would be if x is 3. So wherever we see x in our equation, I'm going to replace that with 3. So I'm doing that. Okay, so before we eliminated a, now we're going to be able to eliminate b. So the left side of my equation is 15 minus 3, so that is 12. And my right side is going to be just 4a. So we find that a is going to be 3, and that's what we did have here. So this is an equivalent expression to 5x minus 3 over x squared minus 2x minus 3. Okay, and that's really important so that we can integrate. Okay, so this integral is the same as saying it's the integral of 3 over x minus 3 plus 2 over x plus 1 with respect to x. Now, since it's more than one term, we can actually integrate each term. So I'm going to do that here. I'm going to integrate the 3 over x minus 3 with respect to x and integrate 2 over the quantity of x plus 1 with respect to x. So I'm going to pull out the constants. Make it a little bit easier for us to identify that when we need the antiderivative, it's going to be the ln of absolute value of something plus c. So in this particular case, okay, if I write this, it is the ln absolute value of x minus 3. I'm not going to write plus c over here because I'm going to add it at the end. If you want, you can write like a subscript c sub 1 and then c sub 2 later. They ultimately combine into one constant. So I don't need to write it twice. We always just write it the once. Now over here I have 2. If you're wondering what happens to my u substitution, since it's just x, it will always work out to be the ln of that x minus 3 or x plus 1. So let me show you the u substitution here. Okay, so you can see how I can evaluate this integral by saying it's 1 over u du. And this is how we get the ln of u, okay, plus c. So I ran out of space, so let me write this at the top. Okay, so let me bring this up. This is what we have so far. And I was just explaining how, like, it's the ln absolute value of u plus c. I was explaining before you only need the one c. Let's substitute that u back in. And now you can tell whoop, that doesn't look like ln. It kind of connected together. You can see what I was saying before, since u is x plus 1. Why I didn't necessarily need the u substitution, but you can always use it. Do be in the habit of practicing using it because it will come in handy. So this is the answer for our expression here. Now with logarithms, you would also keep rewriting it with the property of logs. So if this is a multiple choice question, this may not be your final answer. So let me show you. Okay, so first off, we can have that this is to the third power, because if you have a number in front of a logarithm, you can move it behind and make it the exponent. Another thing that you can do is write it as either a fraction if there was a subtraction sign between my two logarithms, or a product. So you can actually write this as a product. Product, not adding, so let me get rid of that. That should not be there. Let me get a eraser. There we go, much better. Okay, so I probably would leave it at this point, but you can see how there are like alternate forms for the answer. Okay, so it's perfectly fine to leave your answer as this, but like I said, you know, there may be different choices as to how to write it, so I just wanted to give you that option. Okay, good luck.